back. So before we get into the full forecasting process, we're going to learn how to explore a time series in Python. So this notebook contains all the code that you will need to learn how to plot any time series. If that time series is at the monthly level, how to adjust the data so that you take account for the different number of days per month, because that adds some additional noise to the data that's easy to remove. We're going to learn how to pick out trends within time series by running what's called a smoother through that time series. And we're also going to use a process called seasonal decomposition to break a time series down into its trend and seasonal components. So before we start, there's some standard imports. So we're going to import pandas, numpy, matplotlib, and stats models, in particular a function from stats models called seasonal decompose. I'm using stats models version 0.11.1. It's not critical that you use the same version as me, but it is good practice if you can do that. So the data set that we're going to explore is a time series of arrivals at an emergency department. They're adult arrivals, so it's people who are older than 18 years of age, and the data is recorded at the monthly frequency, and these observations were taken between April 2009 and May 2017. Let's have a quick look at the data file. So it's a very simple file. So you've got two columns, one of which is the date and one of which is the arrivals. And we can see that this is monthly start data, and this is the total number of arrivals per month. So using the standard process for time series, we're going to read that data into a data frame that we've called ed month. So the data should be located in your data folder with the file name ed_month_time series.csv. Our index column is the date. We're setting parse dates to true, and our index frequency is monthly start. So let's run that. So I've very quickly read that in. Let's just have a quick look at the shape of that time series, and because that will tell us how many months are in the data. So we've got 98 months worth of data, which is a nice chunky amount. Let's just double check the minimum date and the maximum date. So we can see the timestamp of the earliest date within the data is the 2009-04, and the latest is 2017-05. And the frequency of that data is monthly start. So that's good. We know how to do that already. So then we want to plot that, and the good news is that Pandas makes it very easy to access matplotlib, and in fact many of matplotlib's functions are implemented via Pandas in a slightly simpler way. So the easy way to visualize a time series, if you've read it into Pandas, is to just call the plot method off a Pandas data frame or Pandas series. So that's what we're doing in this cell here. You'll see that I've also passed in a parameter called fig size. That stands for figure size, so that's how big you would like your plot to be. I tend to opt for a 12 by 4. Notice that that's a tuple. So that returns a chart of your time series straight away. If I wanted that bigger, I could have perhaps gone for a 12 by 9. So what you can see is that 12 is the width and 9 is the height. I tend to go for a 12 by 4 for a time series so that it fits very easily onto the page with other things. So we can see here that there's clearly a sort of increasing trend over time. Possibly there's some seasonality within the data, although we'll look at methods to try and pick that seasonality out in a moment. So one of the things you'll probably be doing with this sort of work is producing figures that you then want to add into a report. Again, Python makes that very easy, or Pandas in particular makes that very easy. So when you call the plot method off a pandas data frame or series, it returns an axis object. And then from that axis object, you can call axis.figure.savefig and pass in the file name. And what that does is that saves that to file. So let's run that. So that's produced our figure again, and it's also saved it in an images folder and called it explore.png. Let's just go and have a look at images. So here it is. So that has saved that to a file. So that's just a PNG file. That's something you can then import into a Word document or a LaTeX document or whatever you're using to produce your reports. Oops. So that's quite a basic plot. So we know that Matplotlib is very flexible and it can produce very high quality plots if you'd like it. So the full scope of Matplotlib is well beyond this tutorial. However, I am going to go over some options that I use quite a lot, which I think are quite sensible to learn about early on. So those include the color that you would like to plot it, the line style, so is it a dashed or dash dot, or get rid of the line altogether, how thick, what the width of that line should be, and typically that takes the value of 1, 1.5 or 2, anything more from that is quite chunky indeed. And then if you want a marker in your chart, say for example, if you're plotting multiple time series at the same time, it might be nice to have different markers for those plots. So standard ones are dots, crosses, or triangles. So this first example is going to plot the ED month data. So we're calling the plot method off the data frame. We're specifying a figure size of 12 by 4. I would like the line to be black. I would like the line style to be dashed. That's what two hyphens stand for. I would like the marker to be a circle, and I would like the line width to be 1. So if we run that, we get this plot. So that's a plot, for example, that would work very well if you were printing out in black and white because it's not in color. Now I can change some parameters there. For example, I could have a thicker line and run that again. I don't like that, so I'm going to go back to 1. But I might change my line style. For example, I might have a dash and a dot. Or I might change my marker. For example, I might change it to a triangle and plot that. So very easy to quickly manipulate how your chart looks. And then once you're happy with that, you can then go on and save it again. So at the moment, actually, our y-axis doesn't have a label, which is very bad practice indeed. So it's very easy to do that. We have got this legend here. I'm going to turn that off for the time being, but it's very easy to set a y label. So once you return your axes object off that, you can call some methods. So for example, you can set the y label to attendances. I will just comment out this line for a second and run that. So now we've got our attendances label there, which is a bit nicer. What this third line is doing here is it's setting the limit of the y-axis. So you can see here that we're actually starting at 8,000. Sometimes that can be a little bit misleading to people who've not been involved in the analysis. They may miss that y-axis doesn't start at 0. So I'm going to set the y-axis starting from 0 here up to 12,000. If you've not seen this underscore in a number before in Python, that's just a way to help you as the user read your figures. So you can get rid of that if you wish, but it's something I've got used to doing. For example, if you're inputting very large numbers like 1 million, it's useful to have those underscores in there so you can easily read the number. So if we run that, now what you can see is we've added our label of attendances, but we've now got a y limit that runs from 0 all the way up to 12,000. So what I've shown you is how to settle these things manually. There is a package called Seaborn. And now Seaborn does a lot of things, but one of the things it does by default is improve the appearance of your charts. And all you need to do for that is to import Seaborn and then call its set function. So if we run that, so what that code has done is it's imported the Seaborn package as SNS into your Jupyter environment, and then we've called the set method of SNS. And so now if we just do a basic plot command of the ED month object, we get a slightly nicer formatted chart than we did before. So if we scroll back up all the way to the top, this is what the default plot looked like. So here we've called the ED plot method, and this is what the defaults look like. With Seaborn, the defaults are slightly different. So you can see we've got the bars here which break things up. It's a bit easier to see where 2010 and 2011 end, for example. And we've also got the grid lines going across, which means we can see where the figures are sort of lining up. So that's quite nice. A lot of people use Seaborn to smarten up their plots very easily. And that's something you can do as well. And then all it is the defaults. You would use the other things I would have shown you in exactly the same way. So the data that we've seen so far is really the raw data. Now, one of the quirks of working with raw data at the monthly level is that some of the noise in the data is just due to February having 28 days and other months having 30 or 31 days. So a simple thing to do is just divide through by the number of days in the month. So you get a rate then. So for example, here we would get the average number of people arriving at the ED per day. So it's very easy to get the days in the month. Off the index of the pandas data frame, we just call the days in month property. And that returns the total number of days in the month for each row in your time series. So to do a pandas operation like this, we're just dividing the arrivals column by this value, and we get. I'm saving that in a new. This will be a pandas series called arrival rate. So if I run that, and then let's just have a quick look at the arrival rate. So you can see now that it's a pandas series. We've got the date, but now we've got numbers in the hundreds rather than thousands. If we compare that to ED month, you can see that very similar, but here the values are in the thousands. So now we've got an average. So you've got this point, you've got this decimal point after it because we've divided through by the days in the month. Let's have a quick look at how that changes things. So let's also plot the raw data. So what you should be able to see is that this second time series of the arrival rate is slightly smoother than the one before, where it was raw data. Now that's an advantage in terms of interpretation, and it's easier for methods to forecast that smoother data. So it just is a simple calendar adjustment that gets rid of some of the noise in the data to help us predict easier, and also to see some of the patterns in the easier and not get misled that there are patterns where there aren't. So now that we've adjusted our time series, what we could do is use a simple method called smoothing to explore the trend within the data. So again, Pandas makes this very easy for us as it has a method called rolling. So what this does is it creates what's called a moving average. So to do that, all you need to do is call the rolling method off the arrival rate series, pass in the window size. So the window size refers to the number of values you want to include in that average, and then take the mean. So I'm going to plot this data just so you can see what's going on. So this point here, in 2010, early 2010, is the average of these data points before it. In fact, it's the average of the first 12 data points in the time series. The next data point in this orange smooth series is the average of the 12 data points before that, and so on. So you get what's called a moving average, and you can see that it smooths the time series. And you can pick out the trend here. So you can see between 2010 and 2013, there was growth within the number of patients attending the emergency department. Then there was a period of relative average stability. And then again, from 2016 onwards, there was a growth, and it's potentially flattening out from the start of 2017, although that may just be a quirk at the start of that year. So you can change your window very easily. So we could go for a 6-month moving average instead. And what you can see is the smaller that window size, the less smoothing is applied to the data. So with the 6-month moving average, we can see some of the seasonality within the data, that it goes up and down within a year. If we went to a 24-month moving average, we can see it becomes very smooth indeed. But the bigger that window, the more data you lose at the start of the time series. So this isn't a forecasting technique. All this is a method for smoothing your data to try and understand some of the trends within it. So again, we did this using the rolling method that we called off a pandas series or data frame. That returns an object, and then you need to decide an operation. So you could, for example, I would recommend taking the mean to convert that into a moving average, but you could also call median if you wanted to. And then this code in cell 30, all that's doing is it's plotting that data. So my moving average is stored in a pandas data series called MA6, moving average 6. Let's make it a moving average 6. And then what I'm doing is I'm plotting the arrival rate, then I'm plotting the moving average, and I'm giving it a line style and some labels. I'm plotting the legend of matplotlib legend, and I'm setting the Y label there. So just a bit of matplotlib code and pandas code mixed up to plot that. So an alternative method to smoothing is to use what's called seasonal decomposition. So these are very simple models that try to break the time series into seasonality and trend. So there tends to be two approaches to doing this. The first is additive decomposition. So additive decomposition makes the assumption that a Y value, your observed value, is the sum of trend, seasonality, and a random error. So this model here represents additive decomposition. So what we're saying is that the observation at time t, Y of t, is equal to the trend at time t plus the seasonality at time t plus a random error. So in order to get this together, you first estimate the trend and the seasonality, and then you subtract those values. Multiplicative decomposition makes the assumption that instead of that yt is the sum of those values, it's the product of those values. So it's the trend at time t multiplied by the seasonality at time t multiplied by the error at time t. So here we've got a division that we work through to seasonally adjust the data. Now, if that doesn't make sense, don't worry, because stats models includes a seasonal decompose object. So all we need to do is call that and pass in the arrival rate. So that's our adjusted calendar data, and specify the model that we want. So how do you choose whether it is an additive model or a multiplicative model? So my advice of that is to look at your time series visually and look at how over time the variation in the data changes. So what we can see here is that there is a clear trend within the data, but the spread of values, the variance of the data, doesn't seem to increase over time. So the seasonal fluctuation doesn't increase. Now, when that's the case, it's best to use what's called additive decomposition. If, on the other hand, we find that the seasonal variations are getting bigger over time, like we saw with the alcohol data, then that's a sign that we should be using multiplicative decomposition. So I'm happy here that we should use an additive model. So we run that, and that returns a decomposition object, and then within that we have the different components in the model that we can plot. They are all pandas data frames, which is very handy. So I can just say decomp, which is my decomposition object, .trend.plot. And that's plotted our trend. And that looks very similar to what we got through smoothing, which is handy. But the neat thing about seasonal decomposition is you also get an estimate of seasonality. So what we can see here is how each year, how the different months affect that trend. So we can see, for example, in 2012, in January, we would expect the observation to be on average 20 below the trend. And then if we go up to February, we would expect it on average to be about sort of 8 over the trend on average. So this is your addition. So you have your trend value for, say, 2012, and what I would do is I would then add those particular values from the seasonality estimate to the months, and that would adjust our data. And then finally, once that's been subtracted from our observation, we have our residuals. So this is just the remainder that our simple additive model cannot explain. And the three of these things added together gives us our original time series. So that's what the decomposition is doing. It's taking that time series, it's detrending it, and it's removing the seasonality in order to give us a better view of what is happening within that time series. So from this data, I would conclude that between 2010 and 2013, there was a growth. Between 2013 and the middle of 2015, there was a plateau. And then from the middle of 2015 onwards, there was again growth in the number of patients attending that time series, attending that emergency department in the time series. And then in terms of seasonality, I can see a clear seasonal pattern that in January, it's well below the trend. And then in some of the later months, it's above the trend, and so on. So I can start picking apart my time series and understanding what typically happens over time and within a year. So now we're going to move on to a simple notebook, practical, where you can have a go at this yourself.